This session was on Lewis structures, and we're going to call it Basics 2, and we're going to introduce the concept of resonance. But first we're going to do one practice session on a fundamental structure, and this structure is carbon tetrachloride, CCl4. Now, if you look at the Lewis dot periodic chart below, you see carbon is in group 4. So it has 4 valence electrons. And each chlorine is in group 7. It has 7 valence electrons, and there are 4 of them. So the total number of electrons available for this molecule, other than the interior electrons, are 32. The second position is carbon is the least electronegative. We make it central, and we surround it by the 4 chlorines. We did that. Now, the minimum bond between a carbon and chlorine is 2 electrons. It's not Elmer's glue. It's 2 electrons. So let's draw it in. There's a pair of electrons, 1, 2, 3, 4. That's a total of 8 electrons. We're going to remove those 8 electrons, and we have a total of 24 electrons remaining to be assigned to this molecule. Well, the rule is we start with the outer atoms, and we assign the electrons until we achieve octets. 2, 4, 6, plus a bond is 8. Notice 6 electrons here. Can you see the pattern? 6 times 4. And we have used up every one of our 24 electrons. Nothing to assign to a central atom, and that's good because we don't need any. We have an octet there. So we have a valid structure. We could check with the formal charge very quickly. Chlorine starts with 7 electrons and ends up with 1, 2, 3, 4, 5, 6. Half of this bond makes 7. So its formal charge is 0. It's identical to these 3. And let's look at carbon. Carbon starts off in group 4 with 4 electrons and ends up with 1/2 of these 4 bonds. Remember, we assume that there is no electronegativity between the bonds in formal charge. So we have the ideal molecule with all 0 formal charge, octets. It's a go. But what happens when we run into a molecule such as sulfur dioxide? Sulfur dioxide, it's a nasty, poisonous gas, choking gas. Find sulfur, it's in group 6, it has 6 valence electrons, and oxygen is in group 6 also, and there are 2 of those. So we have a total of 18 available electrons. Now let's go down here and draw the structure. We're going to start over here with sulfur and surround it right angles with 2 oxygens. That gives up 2 times 2, 4 electrons. So how many do we have left to assign? Over here, 18 minus 4, it's 14 electrons. So let's start assigning them around the outer atoms. 2, 4, 6, and that's an octet. 8, 10, 12, that's an octet. And then assign what's left over to the central atom, 2. We have a problem with the central atom. What is it? I hope you notice there's only 6 electrons. It's not an octet. So what we're allowed to do in Lewis structures is, if we have 1 or more pairs of electrons, we can form multiple bonds. In this case, take a pair of electrons here and share it between these 2 atoms. And what we get is a structure, sulfur double bond O, O. And very quickly just whip these electrons in. That is a valid Lewis structure. But the problem with it is there is another valid Lewis structure by simply moving the double bond here. So we can draw it a second time. And we can put a double-headed arrow in here to show that we have two valid structures of the same thing. Now the reality is both bonds are about 142 picometers length. They're identical, yet a double and single bond is not the same length. So neither of these structures shows it the right structure, the true structure. So it's somewhere between the double and the single bond, like a bond and a half. This is called resonance structure. Resonance structure means neither one of these structures is right. Both are valid Lewis structures, but neither one represents a bond that's the same between both sulfur-oxygen atoms. So we're going to use just these two and stop there, and we'll continue with doing some review, perhaps on Basics 1 again on Lewis structures, or go to one of the others. Okay, so we'll stop right there.